All right, so R8 part 2, we're going to be combining all types of factoring. So on the test, it's not going to say factor using this or factor using that. It's just going to say factor, and we're going to have to figure out which type of factoring we need to use where. So in some questions, you may need to factor more than once. The first thing we always want to do is check for the GCF. So that's going to be the first step. Check for greatest common factor. When we have two terms, we check for the difference of two squares. So the difference of two squares, we're always subtracting. And when we factor the difference of two squares, we end up with two parentheses. One of them gets a plus, the other one gets a minus. We haven't done sum or difference of cubes yet. We'll do that once we get into the Algebra 2 stuff. So we can cross that off. So whenever we have two terms, first thing, check for GCF. Next, check for the difference of two squares. If we have three terms, we could check and see if it's a perfect square trinomial. A perfect square trinomial is just one parentheses squared. Or we would just factor regularly. So remember, traditional factoring, we could either have a is equal to 1 or a does not equal 1. When a does not equal 1, that's when we have to multiply the first times the last. So those are two different types of traditional factoring. And then when we have four terms, we factor by grouping. All right, so looking at example 1. What's the first thing I should do? Check for greatest common factors. So what is my greatest common factor between 12x squared and 48? 12. 6 is a common factor, but it's not the greatest common factor. So I'm going to take out a 12. When I divide 12x squared by 12, the 12's cancel, so I'm left with x squared. And then what's 48 divided by 12? 4. So I have minus 4. Can I factor this anymore? Yeah, I have two terms on the inside, so what do I have to check for when I have two terms? See if they're both perfect squares. So we have the difference of squares here. What times what gives me x squared? X and x. What times what gives me 4? 2 and 2. So my parentheses are going to be x plus 2 and x minus 2.
When is it where you need to divide inside the parentheses? Like after
That's if we start by multiplying,
okay.
we would have to divide. Bless you. So this would be our answer. Don't forget, we took out the GCF of 12, so we have to write that in our answer too. So we took out a GCF, and then we factored. So step 1 was I took out the GCF, and then from here, this is the difference of two squares. All right, let's look at number 2. So what's the first thing I should do to factor? Do I have a GCF in number 2? Yeah, they both have an x, so I can take out an x. What am I left with when I take out an x? X squared minus 16. See, x's here, cancel. Can I factor this anymore? So x squared and 16 are both perfect squares. So what times what gives me x squared? X and x. What times what gives me 16? 4 and 4. So I start off with that x on the outside, and then what would come next? X plus 4 and x minus 4. Awesome. So here I took out the GCF. And then the second step was factoring with the difference of two squares. All right, number 3. How can I factor this? I could multiply the first times the last. So negative 9 times negative 1 would be positive 9. What are two factors of 9 that add to 6? 3 and 3. So in my parentheses, I have x plus 3 and x plus 3. What do I have to do next? Since I started by multiplying, what do I have to remember to do? Divide. So I divide both of these by negative 9. Simplify the fraction if we can. So can I simplify 3 over negative 9? What does it simplify to? 1 over negative 3. So that negative 3 is going to go in front of the x. So negative 3x plus 1. And then what does the second one simplify to? Same thing, 1 over negative 3. So the negative 3 goes in front of the x. So negative 3x plus 1. Remember, when we start with a negative, we always want to double check our answer. If I FOIL this out, what is negative 3x times negative 3x? Positive 9. So something went wrong with the signs. So whenever you have a negative out front, whenever we have a negative, we want to take out negative 1 to start. Because when you factor with a negative leading coefficient, there is a chance that we could mess up the sign somewhere. So we want to start by taking out a negative 1. So we're going to ignore all of this, and we're going to start again. So negative 9x squared plus 6x minus 1. So I'm going to factor out a negative 1. So I'm dividing all of these by negative 1, which means I just flip the signs. So 9x squared minus 6x plus 1. Now what can I do to factor? I can multiply the first times the last. So that would give me 9. What are two factors of 9 that add to negative 6? Negative 3 and negative 3. So in my parentheses, I have x minus 3 and x minus 3. What do I have to do next? Divide by 9. So just like before, I can simplify this to 1/3 and simplify this one to 1/3, and the 3 goes in front of the x. So this becomes 3x minus 1 and 3x minus 1. And then that negative that we took out from the start just stays out front. And that would be our answer. So whenever you have a negative out front, we want to take out the negative. We like it when our leading exponent is positive. What is another way I could have factored 9x squared minus 6x plus 1? What's special about 9x squared and 1? They're both perfect squares. So I could have said 3x times 3x and 1 times 1. So in my parentheses, squared would have been 3x minus, because I have a minus in the middle, 1. Which is the same thing that I got here, it's just written twice. So these are the same. All right, next page. So what's the first thing I should check for when I factor? A GCF. What's wrong with this question, though? Do I usually have like an x cubed at the end? No, it's not in standard form. So I want to put it in standard form, and then I'll take out the GCF. So 3x cubed plus 9x squared plus 12x. Now, what is my greatest common factor?
3.
But even better than 3.
3x.
Even better than 3x.
3x.
No, because I can't take out an x squared because the last one's not squared.
Oh.
But I want this to be positive. So what should I take out? A negative 3. So I'm going to take out the GCF of negative 3x. So negative 3x comes to the outside. Then I'm left with x squared minus 9x minus 4. No, minus 3x, sorry. Because 9 divided by 3 is 3. Am I done? Now let's see if we can factor this more. What are two factors of negative 4 that add to negative 3? Negative 4 and 1, perfect. So in my parentheses, I have x minus 4 and x plus 1. And then that negative 3x just stays on the outside. So for this one, I started by putting it in standard form. Then I took out a GCF. And then I just had to factor it normally. All right, let's look at 5. What do you think I could do for 5? I can't distribute the squared. If I undid this part, I would have to FOIL it, which is a little bit more work than what we want to do here. This is my first term, and this is the second term. When I have two terms, what do I have to check for? So go back to that slide with instructions. When you have two terms, check for GCF, which we don't have here. Check for the difference of squares. Are these both perfect squares? Yeah, the first one is x squared plus 8 squared. And then the second one, 36 is a perfect square, and x squared is a perfect square. So I have the difference of squares here. So what times what do you think gives me x squared plus 8 squared? Look, awesome. 8x squared plus 8 times x squared plus 8. It's the same thing times itself because it's squared. So x squared plus 8 is our first term. And then what times what gives me 36x squared? 6x and 6x. So remember, in my difference of two squares, I end up with two parentheses. So first I have x squared plus 8 plus 6x, and x squared plus 8 minus 6x. So here I factored it with the difference of two squares. Now let's see. Am I done factoring? What's wrong with this parentheses here? Is it in standard form? No, let's put it in standard form and check and see if we could factor it anymore. So I have x squared plus 6x plus 8. And I'm going to put the second one in standard form too. So x squared minus 6x plus 8. So let's see if we can factor. Do I have two factors of 8 that add to 6? 4 and 2. So in my parentheses, I have x plus 4 and x plus 2. In my second set, do I have two factors of 8 that add to negative 6? Negative 4 and negative 2. So in my parentheses, I have x minus 4 and x minus 2. So this would be my answer. All right, let's look at number 6. How do I factor when I have 4 terms? Group them. Group the first two, group the second two. What's my GCF from the first group? X squared. So I'm going to take out an x squared. What am I left with when I take out an x squared? 3x plus 1. Be careful here, because when you have x squared divided by x squared, that is 1. It doesn't just cancel out. It is 1. What's my GCF in the second group? Even better than negative 3. Negative 9. So I'm going to take out a negative 9, and what am I left with? 3x plus 1. So are my inside parts exactly the same? Yep. So those go together as 3x plus 1. What would my second group be? X squared minus 9. Can I factor this even more? Which part factors? The x squared minus 9. These are both perfect squares. So what times what gives me x squared? X and x. What times what gives me 9? 3 and 3. So how does that factor? X plus 3 and x minus 3. Difference of two squares gets two parentheses. And then I start with that 3x plus 1. Just don't forget that part in your answer. So next I have 4x times 2x minus 1 plus 2x minus 1 squared. How can I factor this? So if this is my first group and this is my second, my first term and my second term, what do I have in common between these two? 2x minus 1. So what's my GCF? 2x minus 1. So I can take out a 2x minus 1 from both of these. So 2x minus 1 goes on the outside. In my first term here, the 2x minus 1s are going to cancel. So then I just have 4x. And then in my second group, if I have 2x minus 1 squared, and I take away a 2x minus 1, what am I left with? 2x minus 1, perfect. So I took out my GCF. Can I simplify this anymore? Perfect. I can combine my like terms. So that becomes 6x minus 1. And then that 2x minus 1 just stays out front.